Okay, everyone, let's get back for the last presentation from Martin Cmejrek. Just before his presentation, let me introduce him. He worked at the IBM and currently he's the head of research at Telma AI and is the co-founder and VP at the Mama AI. And his presentation will be about natural, natural language querying. And yeah, here goes to Martin.
So I hope I'm sharing my screen properly right now. So so first of all, thank you very much that you have stayed here. It's dark out there, and I'm keeping you from beer. I came up with the title "Natural Language Interface to Everything," but at the end of the day, from my talk, you might have an impression that there were like 3 speakers today with different training, with different careers, and all of them ended up uh, drafting prompts for ChatGPT, training local llama models, and playing with LangChain. So that's actually true, but maybe only partially true. So I will start with introduction of the Mama AI and how it is with our relation to IBM. So some of us met in the late 90s. Most of us met like 20 years ago in IBM. We started as IBM Speech Group. So in the 90s, we worked on the basic technologies of speech recognition, signal processing, speech synthesis. Then in 2014, we started IBM Watson lab here in Prague after being involved in the Watson Jeopardy project as well. But in 2021, we decided to go on our own and to make a living out of what we have learned in AI. My personal story is that I joined IBM in 2004 and I started working on machine translation. I was in New York, in Yorktown Heights, and I was developing a device for the US Marines, the device that could translate between English and Iraqi Arabic and Pashto and Dari. So basically, it was a communication between people. And, you know, the fascination with language also made it to the name of Mama, because one explanation could be man as in mankind and machine communication. So we do many things. We do many projects on how to introduce AI to different businesses. And for those from those successful projects, we tend to make projects. And here is our mental map of different AIs that we do. So here is like communication AI. You know all of them, voice bots and chat bots. It became very popular these days. We do them in text form, in spoken form, in the segment of telephony, omnichannel, you name it. Then we have search intelligence, where Pavel would call it vector store, for example. So yes, we all use the same technology, vectorized representation of semantic space. So we do search AI, but not only on top of, let's say, structured and unstructured documents. We also do it on in the chemical space of molecules, where we find molecules with similar properties, try to predict their properties that could have some impact on drug discovery, such as things whether they can dissolve in fats or water, whether they will be toxic, things like that. We do personalized AI, which is like generative AI for creating personalized messages, videos, learning materials, in different segments like HR, technical, military, things like that. We do metaverse and virtual reality, where again we come from the speech field, so we believe that the speech channel can be very much helpful in virtual reality. We do data science, reasoning, uh, predictive maintenance, anomaly detection, and also we have blockchain product for detecting malicious smart contracts. So we are active in many fields, and today uh, I have picked, and I was instructed to say something about long chains and large language models, and I'm the third person on this stage. So I will try to make it faster and probably go quickly through the demos because we probably have the same opinion on the technology. It's now all about the question of finding the right use case, doing successful POC, and prove it that AI and large language models and how they will be beneficial for the industry. So let's start with our product called Msearch, uh, which is technically quite similar, or basically the technology built on the same background as vector search. So uh, now what it does, uh, a business, imagine that you have some company database, like knowledge base of documents of different kinds. Here for the purposes of demo, I can try like English news, and it's a very quick search. In a fraction of second, I can sift through a database of tens of thousands of text, and I can ask this: did any usage food, did any unsafe, I should ask unsafe, probably unsafe food enter the market? And of course I get relevant documents from the newswire that contain information about unsafe food, and I can ask GPT to summarize it, right? Because nobody actually wants to read all those documents. And I learn about shellfish products shipped from South Korea, etc. So I can quickly search interesting details from the news. It is multilingual, so if I switch it to Czech, I have some explanation here. I can find some information about unsafe food in British supermarkets and get it summarized here in this section, right? If I ask on German data, uh, I can get salmonellen in Schinken. So you see that if I ask this way, the world seems to be very unsafe place and very risky to live in. Now, but how can this make a benefit for your company? So imagine that you are, let's say, an insurance company, and you have customers. You are facing the customers with their real questions. So I can ask, I lost my golf clubs on the way to a tournament. Uh, I have sport insurance. Can I get reimbursement? Right? Probably some typos. Let's see if I get something. So in the Czech terms and conditions, we have find some relevant questions and answers, and uh, get relevant answer. Yes, if you have sport insurance, your lost golf clubs should be covered as long as they are within the insured value. And it gets from the documents that the limit value is 50,000 crowns. So this is some example of POC of that allows quick communication uh, and exact communication with customers. Then, wow, then I have yet another example of how long chains can generate SQL codes or data frame queries. So here I have this notorious example of Titanic passenger list, and I can generate quite surprising sociological insights. Sorry, such as what is the survival chance for passenger classes, and I learn things that are pretty disturbing. First class 60%, second class 40%, third class 20%. So you don't have to learn all these things to be able to find relations and find interesting insights from the data. Okay, so this was an example when your data is structured. But let's go back to the M search and to another successful, let's say, business implementation, and this is semantic search applied to help desk ticketing system, right? So you have let's say a bank that has a large help desk. You have hundreds of operators of that help desk, and they are using, let's say, ServiceNow ticketing system. And so the intuition is that if an employee works on a ticket, you have hundreds of similar tickets that were solved before and probably contain the solution, right? So one of the successful business application of our semantic search and some subsequent large language model agent is to find the most similar help desk ticket and propose solution based on that. So basically, in that scenario, we measure that in 87% of cases we suggest relevant case for the help desk ticket and propose a relevant solution. Okay, so this was the Titanic. Now, these were the tools that give you insight into your data, allow you to search through data. But now here is the other part. If you have some information, how can you communicate it to the people? Here I have some demos that are sorted maybe from the simplest one to more complicated. Let's make it a little bigger. So I guess. No, I cannot make it bigger, sorry. So small businesses, such as hotels, right? Many of them want 24/7 communication with their customer. So here is our Telma chatbot that can be constructed based on structured or unstructured information that you provide about your business. So here is, what is the name of the hotel, how many stars you have, what's the contact address, when does your reception desk opens, ends, and here you have a chatbot that basically can serve your customers pretty efficiently. And I'm trying to make a PowerPoint slide, communicate with and be interactive. I got a problem too because I have to move this toolbar. Sorry about that. Here I can actually type. So I have a family of 4. What do you recommend, right? And I get some recommendation for a suite of 2 bathrooms, apartment, etc. And if I arrive around midnight and need a haircut in the morning, so it will probably suggest me that the reception is 24/7 and that I can get a haircut from 8 to 2 because that's when the hairdressers are open. So this is a simple case of simple chatbot that can be quickly created just based on the information found on your website. Then here is another example. Here is our collaboration with the Czech Army, where we try to recruit people to the army. And again, there are it is the army. So for certain questions, some some responses need to be granted. So for more complicated questions, we integrate the chatbot with semantic search and find relevant document based on semantic search. So if I ask ahoy, there will be some basic chit chat. I guess I will have to refresh the page. Sorry. So you see that the interaction is very quick. I need to speak Czech to it. Máte volné pozice. It will. You see that here is the quick interaction based on intent recognition used for dialogue planning. But I can also speak to it in human voice. I can say, "Jsem programátor," and we will see if.
Prohledala jsem pozice a tyto se mi jeví jako nejrelevantnější. Důstojník, mladší technik. Pokud vás některá z pozic zaujala, neváhejte a klikněte na více.
So based on the semantic similarity, it will search through the current database of open positions and find something from the where my programming skills will be like rewarded and bank, and I am drafted, right? So or if I ask jaká je výplata, again there will be some lang chain again agent behind this, and it will bring me the most relevant pages with that describe the salary. Another use case is in production line, right? You are working on the on the belt, or you are a manager of a shift, and let's say that you are creating, well, here it is about tightening screws. So you are basically measuring the momentum of those tightened screws, and there is some anomaly detection. Some value is here out of limits, and it generates some alarm, some what is it? Anomaly is detected. So it tells me there is some suspicious curve. The slope top parameter is unusually big. So I can ask, give me the torque curve, right? And okay, I guess I have to restart the connection because it did not stay 60 minutes. So give me the torque curve, right? And it will play with the OpenAPI specification of the database, generate the queries, and the dashboard will basically present the right curve so that I can inspect them. I can do zoom to the top. This actually makes sense, especially if you are having hands full of various tools, and you can communicate with it also by spoken language, right? So here you get a zoom to the very end of the curve, and you can do something like, give me some past curves for the reference, and basically you can control this complicated dashboard just with natural language, and you can inspect that this suspicious curve is slightly different than the other one, because basically the plateau is not flat, it's just going up. So you can say, this looks pathological. This is the lingo of the company, right? The plateau is not wide enough, and basically the long chain detects that the anomaly was resolved it will make a conclusion that this is actually a bad curve, bad tightening of the bolt, and it will create some JSON message and logs it into the system. So this is another use case where we try to make long chains and large language models helpful in the business process. So that's, I guess, all from the part of the communication AI. Now, I mean, language interfaces to and text interfaces to different modalities. Now, another segment where this can be helpful is if you have some information and you either want to collect information from people or give them some notification so that they pay attention to that notification. So here is an example of our collaboration with a pharmaceutical company about about when they do clinical studies. So they check whether people take medications and do some statistics about it. So let me play you some example how a conversation in spoken modality can look like.
Dobrý den, paní Závěrková. Tady je váš digitální pečovatel Tomáš. Jaký jste dnes měla den?
No, hodně horký, ale šlo to.
Dobře, to jsou pro mě důležité informace. Trápilo vás dnes něco na vašem zdraví?
No, špatně se mi dýchalo.
Děkuji, že mi takové věci říkáte, moc si toho vážím. Vzala jste si dnes léky, které si každý den berete?
Ano, vzala.
Výborně, tak to je dobře. Zavolám vám zase zítra, abych se ujistil, že se vám dobře vede. Děkuji vám, paní Závěrková, a přeji hezký den.
Taky tak, Tomášku.
So you can see that after a couple of calls, people even built like human relationships with our voice bot. They call him Tomášku. Tomáš is the name of our artificial voice, but it's also the name of the virtual person that basically checks elderly people whether they take medication. One more example where we integrate spoken dialogue with some business. For example, if you want a new connection from Petřiny.net, it's an internet provider, you can just call there, dictate, it will ask you for your address, translates it to Ruyan code, and finds in the database whether there is optical cables or something slower. So it will directly give you a quote. I will just quickly skip to the part where you dictate the address.
Abych ověřil dostupnost našich služeb, potřebuji znát vaši adresu. Nyní mi prosím nadiktujte adresu místa připojení včetně města. Pobřežní 21 Praha 8. Výborně. Do své databáze jsem si uložil následující adresu. Město Praha, ulice Pobřežní s číslem popisným 665 a s číslem orientačním 21. Je to v pořádku? Ano. Strpení prosím, projdu svoji aktuální databázi. Na této adrese vám nabídneme internet na telefonní síti našeho smluvního partnera s tarify od 490 Kč měsíčně a rychlostí připojení do 100 megabitů se smlouvou bez...
So you can see a lead was generated, and a couple of hours later, a businessman will call that person and signs the contract. So that's another use case. Here is an example of our collaboration with eShop, where we call people who have ordered packages to local stores and they did not pick it up, because that's something where the retailer has to pay like 100 crowns for each package to put it back on shelf. So here is an example of outbound campaign where we called like thousands people a day to remind them to pick up that parcel, to prolong the period till it's sent back. And this actually has a very quick return of investment below 1 month, just because we have shaved off that portion of unpicked up picked up parcels. So here you can see how the campaign goes. Maybe later, or if we have internet connection, and maybe not. Oh, it's going. So the green calls are finished calls, people who picked up and responding something meaningful. You can see that most of about one half of people will decline the call if you call them. So after a time, you can repeat the campaign and try it for the second time. It just depends on how you configure your meta parameters. But this is an example of a large scale massive campaign. Now the second round is going on, so you can see that we will end up doing around 50 to 50 or more than that of successful calls. So this is an example of our Telma outbound campaign. It's very easy to script your own outbound call campaign. It's also integrated with GPT, so the conversations can be very fluent. Okay, the last thing that I will show is just an example of our text to speech product and voice. Maybe that you have noticed that a couple of months ago we have built together with Seznam a robotic moderator where especially in the night hours there is a robotic moderator called Hachiko, which has and she has very natural voice. Actually, here on the web on the there was a questionnaire where people voted and tried to guess which of the two voices, the natural one and the synthetic one, was the robotic one, and they actually got it the other way around. So let's say the statistical significance, or it was very difficult to guess it. I will play you both examples.
Na webu pro ženy.cz najdete tento týden zajímavý článek, který se věnuje 5 slavným vůním.
So that was sample A.
Na webu pro ženy.cz najdete tento týden zajímavý článek, který se věnuje 5 slavným vůním.
So it's really difficult to distinguish that, and here the difference is that the voices can explain more, can express more emotion, right? The difference is from the typical text to speech voices, where the actors in the studio are instructed to speak like flat sentences so that they can be reused in many contexts. They are instructed to speak without emotions, and we basically built the voice that contains emotion and is really natural. So that's another example of our products that we are working on. So I guess the time is running up, and I think it's about the end of the slot. So thank you very much for your attention, and if you have questions, please ask them.
Thank you very much for the presentation. And now let's jump straight to the questions. Let me just share my screen real quick. Okay, so first question is, what is your favorite Mama AI project?
Well, all of them are favorite, and Honza Vystrčil is here, so I cannot tell, right? But we have the reason why we left the big corporation and started Mama AI is to have fun. So and we are having fun, I guess, quite a lot. So I will not answer.
Okay, so next one is, how hard is it to collaborate with the army?
It is. I must say that the Collaboration was very, very good. I mean, there were like rules, but what I was surprised that if any date was promised, it actually happened to that date. So it's a positive experience, and also as IBMers, we have a long history of successful collaboration with the army from back in IBM times. So I guess we were not surprised. We basically saw what we expected.
Thank you. And since you're the last, we have 2 more questions. And so, does somebody check the answers like difficult breathing from the medical point of view to prevent potential health issues?
Well, currently in this demo we don't, but there are things that we check, and what we maybe in other scenarios we can detect emotions of the person, either of the operator or of the customer. That's, for example, useful in help centers so that you can detect problematic calls, like where people are exciting and yelling at each other. Another thing, we detect cadency. So and it's actually, and we modify the speed of our text to speech to the cadency of the customer, because it actually improves the success rate of the collaboration. So it's good to match those speeds. We can get with reliable accuracy the sex of the person. What else? We can get like with the precision to the decade, we can classify the age of the speaker. So these are the things that are that we currently extract from the spoken signal. We have read papers about detecting breathing problem or even COVID problems from the speech. So this can be done with certain precision.
Thank you. And the last one is, in which area do you see the greatest potential for growth?
Well, currently, as you have seen it, we are all playing with local language models. We are playing with the large GPTs. We are playing with lang chains. We are trying to build agents for whatever practical tasks, and we are all in search of the of of a successful POC application, right? So that's where we currently invest a lot of time, and where we believe there will be a breakthrough. So you have seen the examples that we are trying, and that's where we have our bets on.
Okay. Thank you very much for your presentation, and a round of applause, please, for Martin.
Thank you.